is here to present you a small experiment about electrostatic force. Electrostatic force is another kind of non-contact force which is observed in this experiment. First, you have to take a scale, then gently rub it to your hips. Then take it to a flowing water. You can see that water gets attracted towards the scale. This is because when we rub the scale to our hairs, it acquires the property of electrostatic force. Electrostatic charges can be negative or positive. Electrostatic charge exerts a force is called electrostatic force. In this experiment, it is concluded that electrostatic force is another kind of non-contact force. Thank you.
Hello everyone, this is Pranali and today I am here to present my model for science exhibition. My model is based on Newton's third law of motion. Basically, I have made a pendulum wave. As the pendulum swings back and forth, they make amazing patterns. That's because each pendulum has a slightly different period, which is the time it takes to complete a full swing. A pendulum's period is set by how long its string is. A long pendulum has a long period, which means it takes a longer period of time to swing back and forth. A shorter pendulum has a shorter time period, so it swings faster. Each pendulum swings a little bit faster than the before because when we release them at the same time and height, their different periods make them go in and out. They swing together, then move like a wave.
Hello everyone, my name is Anushka Thorar and today I have got a golden opportunity to participate in the science exhibition organized for 8th standard, and our topic is force and motion. So let's start. Force can simply be defined as the push or pull of an object due to any external force. For example, a boy wants a book from drawer, so he will need to pull a drawer to do so. This shows that the boy is using force on the drawer. There are two types of forces, balanced force and unbalanced force. Here the difference between them is explained. When the force in magnitude is same but acts from different direction on the body, it is balanced force. When the force in magnitude is different but the direction of motion is same, it is unbalanced force. There is no change in the state of rest or uniform motion of an object. Net force is different between the forces. Result is no motion in balanced force. Moves in direction with more force in unbalanced force. Now here is an experiment. We all played carom and we need to strike the striker to put the coins in holes. But if there is no force on the striker, will it remain in rest position and there will be no motion. Thus, we need to apply force by our finger on the striker to create the motion so that it will hit the coins. This shows us that an object can only be in motion if there is force acting on it, and no object can move without motion. Now motion. An object is said to be in motion if it displaces its position from one point to another due to any external force acting on it. For example, when a car moves, it is said to be in motion, and when it is stopped, it is not in motion. Newton's law of motion. First law. Objects are tend to be in motion and objects at rest tend to stay at rest until and unless an unbalanced force acts on it. Law number 2. The force acting on an object is equal to the masses of an object into acceleration. Law number 3. Every action has an equal and opposite reaction. Experiment. The following girl is skating a skateboard on the road. She had moved from a specific point to another, but due to what? It is just due to the force that she enforced by her leg by pushing her forward. Thus, due to force acting on her, she is tended to move and change her position from rest. And by this, we can conclude that how, due to force, she is in motion. Thank you.
Hello everyone, I am Rajaswi and today I am here to present my model for science exhibition. My model is based on Newton's third law of motion. Basically, I have made Newton's cradle. The Newton's cradle is a device that demonstrates the conservation of momentum and the conservation of energy with a swinging speed. One spear at the end is lifted and released. It strikes the stationary spears, transmitting a force through a stationary spears that pushes the last spear upward. The last spear swings back and strikes the nearly stationary spears, repeating the effect in the opposite direction. The device is named after 17th century English scientist Sir Isaac Newton. It is also known as Newton's pendulum, Newton's ball, or Newton's rocker. A typical Newton's cradle consists of identical metal balls suspended in a metal frame so that they are just touching to each other at the rest. Thank you.